Hello, and welcome to another edition of the Daily Bolt with your host, Dr. Jeff Tilley. Today's topic, bird migration and climate change. So today's Daily Bolt topic comes to us from the University of Massachusetts Amherst, a research university. I know a couple of people who've graduated from UMass. It's got a famous basketball team. They don't do well in football or a lot of other sports, but they do have interesting research programs. And this one in particular comes from basically the merging of ornithology and climate science. And the authors, which actually are not only from UMass, but also include researchers at Colorado State University and the Cornell Lab of Ornithology, have done a study to look at bird migration patterns over about a 20 to 25 year period from radar data. And those of you who have seen radar charts on your weathercast or on a national weathercast from the news program, or even if you have an app on your phone that has the radar on it, you may not realize that it is possible to detect birds and even smaller insects using radar if you know what to look for and how to look for it. And so these authors have looked at about the last 25 years of radar data. That's a lot of data. It would take most researchers and most research groups a fair amount of time to look through this data once they get access to it. What is unique about this study, even more than the results, because as you'll see in just a few minutes, the results are not particularly surprising. But the methodology is interesting. I'm not sure how well it really works. The source that I saw the study reported on did not have a lot of the data involved, and unfortunately, it's a very expensive subscription to find this article and look at all the details of the methodology from this website, Nature Climate Change. Although the main portion of what they have put together is available and is downloadable, I have not had a chance to actually see if I can reproduce their results. And it shouldn't take that long, because what they claim to be able to do is to use an artificial intelligence program to go through the radar data, have the program learn what to look for, and be able to then analyze the data based on that determination of what to look for pretty much by itself. And so instead of taking about a year for this to happen, they were able to do it in a matter of days. Now, that itself is interesting. It's a tool called MistNet, and the name is not related to mists of water. It's basically related to the fact that the signature of birds and insects is very down at the bottom end of the radar detectability range, and you do have to really know what to look for to separate the radar signal from what we call ground clutter, which is a pattern that shows up on radar when the radar beams intersect buildings and topography, other natural features, and even things like radio towers. So what the study found is not a huge surprise over the period of record. We know that there has been some warming in climate in the global arena and in general across most of the continents, across much of the actual calendar year over the last 25 to 30 years. That's no surprise. We already have known that, and we've talked about the issues with the analysis of that data and the interpretation in previous podcasts, and we'll probably do more discussion of the interpretation in future podcasts. For this podcast, we're focusing only on the spring bird migration period. And the reason we're doing that is, according to the researchers, the fall results aren't quite as impressive, and that actually brings me to one of the concerns I have with the study. We'll get to once I get through the results. So, if we consider the fact that over the last 20 to 25 years, the climate has been warming, we might expect spring to come a little bit earlier. We might expect the bird migration patterns to show a shift to earlier in the calendar year. Lo and behold, that is what their study shows. And, that might bring to anyone's mind the question, well, this makes perfect sense. It's common sense. Why did we need to spend money on a study? And who knows exactly how much money? I don't. But why would we spend money to fund someone to figure out something that just makes common sense? Well, occasionally, common sense and intuition are wrong, and we find results that are counterintuitive. And the fact that the fall migration doesn't necessarily show a similar shift to a later time nearly as well does bring into question some issues with the methodology, and maybe the methodology of using artificial intelligence to go through the radar data is the real value of this study, and maybe the reason why it might actually have been worth funding. The problem that you can have with radar data and an artificial intelligence algorithm is it does learn as it goes. And so it picks up on patterns and it learns from those patterns as it goes along. And what has been found in other types of studies that have used artificial intelligence networks or neural networks is that there can sometimes be biases that get introduced, biases where the results are too conservative in certain ways because outliers get thrown out as not being part of the group that the program has learned to consider as part of the formal result. So in this case, what I'm talking about here is that the radar data may have some periods where a human observer might interpret it as ground clutter, it might be interpreted as birds, it might be interpreted as insects. On occasion, these are very difficult to separate unless you really know the topography and other characteristics of how the radar beam is behaving. Ground clutter is something that can often be filtered out when you do that. But if you don't know that, and an artificial intelligence program might not know that for every possible radar site in the country that's looking at, to enough certainty that it won't throw things out that maybe it shouldn't be throwing out. And that can skew and bias the results. The fact that the fall results are not as robust as the spring results suggests that that's certainly a potential problem for at least the fall migration patterns. But if there's a problem with the fall, in terms of how the algorithm operates, there may well be a problem with the spring as well. And so I have to take a little bit of the result, even though it makes perfect sense and it is logical, it's reasonable. I have to be a little skeptical of how robust it is just because of the fact that any artificial intelligence algorithm, unless it's been very, very, very thoroughly validated, has, at least to our current development level, the ability to skew results and miss things that shouldn't be missed in terms of outlier data. So this is something that maybe if I get enough time and can get access to the radar data, I can rerun it myself and see what happens and maybe have a better understanding of exactly how well this really works. The authors claim that the algorithm works almost as well as a human. There's that word almost that is kind of key there. And the question is, what's the sample size of their test data that they looked at to make that determination? If that test data doesn't have any of these types of outliers that I'm talking about, that test evaluation may not be very accurate either. So it's just another way to think about the fact that most science has uncertainties. I've kind of harped on this theme before, and I'll harp on it again right now. Almost any study has a degree of uncertainty in it. It's not fact, and in many cases, the uncertainties often end up being larger than what gets commonly reported. So beware when you see certain science results, and be sure that you keep in mind a little bit of healthy skepticism, just a little, not necessarily a ton, but a little bit of healthy skepticism that maybe there's enough uncertainty in the results. Let's have some other people redo this, see if they come up with the same result. The more people that can reproduce this result, the better the chances that the result is actually accurate. That's all for today. I'm Dr. Jeff Tilley for the Daily Bolt. Good night, good afternoon, good morning, and God bless.